In this video, I introduce text-to-image diffusion models based on transformer-based large language models. Imagen is a text-to-image diffusion model for high-fidelity image synthesis, which is based on transformer-based large language models in understanding text. Text embeddings generated by pre-trained large language models on text-only corpora enhance text-to-image synthesis. Imagen uses the frozen large language model encoder, as shown here, to map the input text into a sequence of embeddings. And the text image diffusion model, as shown here, followed by two super resolution diffusion models, as shown here and here, to gradually generate high resolution images. Pre-trained large language model understands the visual meaning of the arbitrary natural language text inputs. Cascaded diffusion models convert Gaussian noise distribution into samples from a learned data distribution via iterative denoising process. A diffusion model X theta caret is trained on a denoising objective of the form here, where X and C are data conditioning pairs. T sampled from U, E sampled from a normal distribution, and alpha T, sigma T, and omega T a function of T that influence sample quality. X theta caret is trained to denoise ZT into X using the objective here. Sampling starts from a pure noise distribution Z1 and iteratively generates distributions from ZT1 to ZTT. That gradually decrease in noise content. These distributions are functions of the X predictions here. Classifier-free guidance in Imagen jointly trains a single diffusion model on conditional and unconditional objective via randomly dropping condition C. For example, set C is empty with a 10% probability during training. Sampling is performed using the adjusted X predictions here, where E theta ZT C and E theta ZT are conditional and unconditional E predictions given by E theta, and omega controls the guidance strings. Imagen uses the cascaded diffusion models 64 by 64, 256 by 256, and 1024 by 1024 with UNet structure combined with cross-tension and ResNet, as shown here, here and here. The image generator is a condition on the text embeddings via a pod embedding vector, as shown here. The text embeddings concatenated with key and V of the input go through cross attention process, as shown here. Since E theta is a function of time t, the time step embedding indicates the relative position of samples in the time sequence during the training. Here is the Imagen architecture. This is the input noise distribution. This is the prompt text, and this is the high resolution output. This is a cross attention over 4 contextual text embeddings, as shown here. For more details, please check with these references. Thank you. Bye.